So welcome to this week's lesson, and this week we are going to be looking at the halogens, and the halogens are in group 7 of the periodic table, so you can see them just here. So we're starting at the top, we have fluorine, then chlorine, bromine, iodine, and down at the bottom we have astatine. So for our learning aims for this week, we're going to be starting by looking at the physical properties of the halogens. Then we're going to consider the displacement reactions of the halogens. And in these displacement reactions, we will be able to use the information there and also the information from electron arrangement to describe and explain how the reactivity changes as we go down the group. And finally, we'll look at writing some word and symbol equations for the reactions that we see in today's lesson. So here we have got 4 of the halogens in jars. So we've got fluorine in here, chlorine, bromine and iodine. So here fluorine, very pale gas, chlorine there we can see a bit more. This is the bromine and there is the iodine. And so you can see there as we went along we started with gases and then we've got bromine here as a liquid and iodine there as a solid. Both quite volatile, so we still see these gases coming off them, but it's the first two, fluorine and chlorine, that are actually gases. So we have fluorine here, which is F2, then chlorine, Cl2, bromine, which is Br2, and iodine, which is I2. And gas at room temperature for fluorine, gas for chlorine, liquid, so there's gas coming off it, but down here at the bottom there's that orangey brown liquid, and then here at the bottom of this jar we saw when we zoomed in earlier there is a black grey solid. So what we're seeing is that as we go across here, which is actually as we go down the group in the periodic table, we're seeing that our melting and boiling points are increasing. So melting and boiling points increase down the group. So what I have here is I've summarised the physical properties. So we have the appearance, the state at room temperature, that means gas, liquid or solid, and then what's happening with the melting point. You don't need to remember numbers for melting point, you just need to know that the melting point increases as we go down the group. And the reason this happens is because our molecules are larger as we go down the group. And we can see that here, we can see that the mass number is larger as we go down the group. So they're larger and heavier. That's the mass number for the atom. And remember that these molecules are made of pairs of atoms for the halogens. So fluorine is F2, chlorine is Cl2, bromine is Br2, and iodine is I2. So that's what we have when we have a sample of fluorine, chlorine, bromine or iodine. It contains molecules, and those molecules are made up of pairs of atoms. So that's for our group 7 halogens. Remember there are non-metals on that right hand side of the table there, and they're going to go around in pairs. And we can see that the relative molecular mass increases going down the group. So what I want us to consider here is the electron arrangement of the halogens. So if we look at fluorine, let's remind ourselves how we work this out. We're looking here at the atomic number or proton number, and that tells me the number of protons, and it also tells me the number of electrons. So I want you to just take a piece of paper and have a go for yourself at drawing that electron structure for fluorine and for chlorine. So if we take a look at fluorine, 9 electrons, remember I have 2 in the first shell, so that means my remaining 7 electrons are going to go in the outer shell. And I've paired them up there, 2, 4, 6, 7. For chlorine, 2 in the first shell. Remember we put the maximum number in we can. So the second shell has 8 electrons. So that gives me 10 altogether. So that means I've got 7 left to make my 17 for chlorine, which I get from the proton number. So there we go. There are my 7 electrons. So for the atoms, for fluorine, I've got that electron structure or electron arrangement of 2, 7. And for chlorine, I've got 2, 8, 7. So what do I notice about the halogens? I notice that they've got 7 electrons in their outer shell. And that fits with them being in group 7 of the periodic table. Remember, the number of electrons in the outer shell is equal to the group number of the periodic table for everything in group 1, 2, 3, 4, 5, 6 and 7. And if you remember, we spoke before about how all the elements are trying to get that full outer shell of electrons. So in both cases here, they're trying to get an outer shell of 8 electrons. So the easiest way for them to do that is to gain 1 electron. So fluorine wants to gain 1 more electron to have that 2, 8 structure, which is what it would have in its ion. And the same over here for chlorine, that wants to get the 2, 8, 8 structure to be that, have that stable noble gas arrangement. And because they would have each gained a negative electron, that would give each of them a negative charge. So if you just want to pause the video for a second, just as a reminder of what we did a few weeks ago, you can have a go at drawing the electron arrangement for the ions of fluorine, so that would be the F- ion, and also for chlorine, which will be a Cl- ion. So have a little go at that now. Here's what you should have: 2 electrons in the first shell, and then 8 in the second shell here for fluorine. That's what gives us our F- because it's gained that negative electron. And the same here, we have Cl- because the chlorine has gained 1 negative electron. And therefore we have 2 in the first shell, 8 in the second shell, and 8 electrons in the third shell. And remember that once these atoms have gained these electrons to become ions, their name is slightly different. So this is fluoride, it's a fluoride ion, and this is a chloride ion. And that's what we see when the group 7 elements react with some of the other elements from the periodic table. For example, with group 1 metals, we would see the group 1 metal would lose its electron, whereas from the outer shell, whereas the group 7 elements will gain that electron that has been lost by the group 1 element. And so we end up with those compounds, those ionic compounds, things like sodium fluoride, sodium chloride. And we'll see more of that later. You'll see more of that in the bonding topic as well. Well, what does all this mean for the reactivity of our group 7 elements? So to react, these group 7 elements need to gain electrons. So let's consider how easy is it going to be for them to gain electrons. Is it the same for every group 7 element that we have, or is it going to be different? Well, an electron's negative, so it's attracted by the positive nucleus. And if we think about this positive nucleus that we have here in the centre, the attraction between the positive nucleus and the outer shell electron is going to change as we get more shells of electrons. So this is very similar to what we saw last week when we were thinking about group 1. But in that case, group 1, they need to lose their outer shell electron to react. So that was all about making it become easier for that electron to be lost. In this case, this element here, this nucleus in the centre, is trying to gain another electron there. But straight away we can see that this outer electron is further from the nucleus in chlorine than it is in fluorine. So as we go down the group, these elements, these atoms, are getting larger. So the size increases going down the group. It's the size of our atom. And this means I've got less attraction for my outer shell electron. So if I have less attraction for my outer shell electron, it's more difficult for me to attract a new electron into that outer shell. So therefore, my group 7 elements are going to get less reactive as I go down the group as they are getting larger. This means that fluorine is going to be the most reactive halogen. Okay, it is the smallest at the top of the group, and my halogens are getting less reactive as we go down the group. So the reason for this is because the atoms get larger and there is less attraction between the nucleus and the outer shell electrons. So all the while these halogens are trying to gain an electron into their outer shell, but as the halogens get larger, as halogen atoms get larger going down the group, it becomes more difficult for them. There's less attraction between the nucleus and the outer shell electrons. So we have most reactive here at the top with fluorine, and we can predict therefore our least reactive is down here at the bottom with astatine. In this experiment, we're going to look at the displacement of different halide ions from their solution by halogens. So we've got chloride ions, bromide ions in each of these little spots in the tile, and iodide ions. And then we're going to add to them chlorine, bromine, and iodine. So that is how it's going to work. So first of all, we would need to put some sodium chloride in each of our little dimples going across here. And we can just add a few spots of that in. And this is a colourless solution. And we can do the same here. We've got some sodium bromide, also colourless, sodium iodide, also colourless. So each of those solutions, the sodium part of it doesn't matter. It's the chloride, the bromide and the iodide which currently are dissolved in the solution, and we want to see if we can take chlorine, bromine or iodine and push them out of that solution to prove which one is the more reactive. So if we add chlorine, suddenly we will get a kind of browny orange colour in our sodium bromide dimple. In our sodium iodide we get a darker brown colour. If we add bromine, we will see the sodium iodide one would change, but none of the others. And for iodine, we would see no change to the original colour of the solutions. There may be a little bit of colour because the iodine solution is going to be a kind of brownish colour. The same with the bromine solution, we'd have a kind of orangey colour there. But in terms of the actual change from our original sodium chloride, sodium bromide and sodium iodide, these would be the things we would see. So what we would have seen in each case here, where we're looking at the sodium chloride, is, well, we're not interested in this one because chlorine with chloride makes no difference. So here, the chloride ions in this one here are staying in the solution, and there would be no change of the bromine solution that's added. Then here in this one, again, no change. In my second row, when I add chlorine here to the sodium bromide, I would see a kind of orange brown solution. So I would have a change there. And that change tells me that a displacement reaction has happened. And what's happened is that my chlorine, my Cl2, which I've added, has pushed my bromide, which is in the sodium bromide, out of the solution. I now have Br2, that's what that orange solution is, and then I've got NaCl left behind. The chlorine is more reactive, so we can kind of think of it as the chlorine stealing away the sodium from the sodium bromide, and the bromide being pushed out and made into Br2. Bromide and bromine don't need to consider, so nothing would happen there, it's just reacting it with itself. Remember, the sodium's not really involved, just swapping around. Then with the iodine and the bromide, no change again. So I just have the original colour of the sodium bromide. In practice, in the lab, if you did this, you'd also have this brownish colour of the iodine, but there'd be no change that had actually happened. That'd just be its original colour. Then here we've got the sodium iodide with the chlorine, and here we would see it would really be a kind of dark brown solution as our result here. Let's put that for solution, okay. And again, this tells me that I've had a displacement reaction, and in this displacement reaction, the more reactive chlorine has stolen away the sodium from the sodium iodide. That leaves the iodide pushed out, becomes iodine, and I end up with NaCl. That's what that brown colour is. In the same way as here with the Br2, it's the Br2 that is the orange solution, the bromine. That's what we're seeing there. And then in this one here with the Br2 and the iodide, again we're seeing a dark brown solution. So that is telling me that my iodide has been displaced. So another displacement reaction, but this time it's the Br2 that is more reactive, stealing away that sodium from my NaI. So that becomes I2, that's what my brown solution is, and then I am making NaBr. Okay, so that is my dark brown solution there, is my iodine. One thing we need to look out for in all of these cases is balancing of equations. So remember, we've seen this a few times before. It's always a bit tricky, but we just have a look through them and we can see that if we put a 2 there and a 2 there, that means I've got the same number of each element on either side of the arrow. I'm going to do the same on this one and the same on this one. So that is a bit tricky. It's just something to look out for if you do learn these symbol equations. If you're using them, then it's really great if you can also balance these equations. Okay, that's what we're ideally looking to be able to do. So let's take a look at the word equations for those displacement reactions. Let's consider if we had fluorine. So it wasn't one that I just talked about in the experiment there, but this can also happen. So if we've got fluorine, which is extremely reactive, so that's why we wouldn't use it in the school lab, that is much more reactive than the chlorine. So what will happen is that your fluorine will displace the chloride ions from the solution. It's kind of stealing away the sodium. So what we get as a result of this is we end up with sodium fluoride. So the most reactive thing steals away the sodium, and we change the end of the name when it's bonded to the sodium. And the other thing, which was less reactive, it's lost the sodium. It's gone back to its original name from its periodic table. So that's why we get sodium fluoride and chlorine. And so if we wanted to do a simple equation of that, we can do F2 for fluorine, because remember these group 7 elements are always going around in pairs. Then we have NaCl for our sodium chloride. And so I want you to just pause the video and I want you to write what the products are and also see if you can balance that equation. So hopefully you got NaF for sodium fluoride, Cl2 for chlorine, remembering that the halogens always go around in pairs when they're just the halogen on its own there. And then we've got to balance this. So I need to have 2 fluorines on this side. Remember, the number always has to go in front. I can't put things in the formula. That's going to change my formula completely. I just can change how many I have of that. So I've got 2 NaF. That then means I'm going to have 2 sodiums. So I can put a nice big 2 there, which also then helps me to balance up this Cl2 here. So that's my final balanced symbol equation for the displacement reaction of fluorine with sodium chloride. So I want you to have a go at writing these displacement reactions for these 3 different equations here. So did 3 different reactions: chlorine and sodium iodide, bromine and sodium iodide, and chlorine and sodium bromide. So have a go at writing the displacement reaction word equation and also the balanced symbol equation. Don't forget, all of the halogens are diatomic, so they always go around in pairs. So pause the video now and have a go. And here's what your answers should look like. So we have our chlorine and sodium iodide. So looking at very carefully that we've then got sodium chloride and iodine. Balanced symbol equation, Cl2, 2 NaI, giving 2 NaCl and I2. Then we have the bromine and sodium iodide. Bromine's more reactive, so it will have displaced our iodine, so we end up with sodium bromide and iodine. Remember to change those endings. So that's Br2, 2 NaI, 2 NaBr and I2. Always making sure you've got an arrow here as well, not an equal sign. It has to be an arrow in all of these cases, okay? And then this one, we've got chlorine and sodium bromide, gives sodium chloride because the chlorine has displaced the bromide ions and given us bromine, Br2. So Cl2 plus the 2 NaBr gives us 2 NaCl plus Br2. So well done if you got all of those right. If you didn't, have a little look at the things that you didn't get. It might have been the balancing of the equations perhaps. It might have been remembering that these needed to have the 2 on the end. So make sure you have a little look at those. You could think about practicing them again as well. Okay, now it's time to consider what we have learnt during this session and check through our learning aims one by one and see what we can remember and what we think we know. So first of all, we looked at the physical properties of the halogens. So this was where we had a look at the video. We could see the colours of the halogens, and we also could see the states at room temperature, so whether they were gas, liquid or solid, which told us that the melting and boiling points was increasing as we went down the group. And we also considered the fact that these molecules are made up of 2 atoms each, and that their molecules are getting larger and heavier as we go down the group. We then started to think about the electron arrangement, and this led us to being able to describe and explain how the reactivity would change as we went down the group. So remember, we're always thinking here about going down the group. And we said that as we go down the group, the reactivity is decreasing. And we have our most reactive element here at the top of the group in fluorine. And the reason for this is because it's the smallest of our atoms, and therefore the outer shell electrons are not very far from the nucleus, so there's greater attraction between the outer shell electron and the nucleus, so it's easier for fluorine to attract that extra electron that it needs to fill its outer shell and become a fluoride ion. And that's why when we had the displacement reactions, we noticed that if something was higher up the group, so for example chlorine, it would displace the ion of bromide or iodide from the solution in order to form bromine or iodine, and the chlorine would end up becoming the chloride ions in the solution. And that's all because the chlorine is more reactive than bromine and iodine. And we also looked at being able to write word and symbol equations for those reactions. So there's quite a few different things going on in this lesson. The displacement thing in particular can be a bit tricky to get your head around, so don't worry too much if you didn't get that first time around. Just have a little bit more practice on that. Pause the video a few more times and look over the notes there, and hopefully you'll start to feel more confident about that. That is us all done for today. So well done, you've worked hard. Hopefully you'll be able to go now on to show my homework and have a look at the educake that's on there, have a look at the past paper question, and apply some of the knowledge that you picked up during this session.